So today we're going to be looking at multiplying and dividing fractions, which requires to do a little bit of nuance compared to multiplying and dividing decimal numbers or whole numbers, but ultimately it's not too terribly difficult. If you know how to multiply fractions, then division is basically 99% the same thing with a little twist at the beginning. But we'll go over that. So, how do we multiply fractions? Well, the first thing is we can actually reduce the size of the numbers in the fractions by canceling, or sometimes called cross-canceling, the values on the top with the values on the bottom. This makes the overall fraction smaller and therefore easier to multiply and saves us a little time at the end, so we don't have to simplify it as much at the end of the problem. But there are three rules you have to keep in mind about cross-canceling, because once people learn about this, they want to try it every single time they have any fraction, no matter what they're doing, which isn't the case. You can only cross-cancel, or more probably, you can only cancel numbers in a fraction if you are multiplying and one of the numbers is on top and one of them is on bottom, and the two numbers can be divided by the same value. So all three of those rules have to be satisfied. So for instance, let's say I have two fractions. We'll call this fraction times fraction. We'll say I have an 8 on top and a 12 on bottom. That could cancel. I can cancel the 8 and the 12 because one's on top, one's on bottom. I am multiplying, and they can both be divided by the same number, namely 2 or 4. Let's say, however, that 12 was instead an 11. I am multiplying. The 8's on top and the 11's on bottom, but they can't be divided by the same thing. 8 can be divided by 2, but 11 can't. 8 can be divided by 4, but 11 can't. 8 can be divided by 8, but 11 can't. 11 can be divided by 11, but 8 can't. And of course, they can both be divided by 1, but that won't make them any smaller, because dividing by 1 just gives you back the same number. So in this case, I can't cancel because there's no common number to cancel with. And let's say one more example. Let's say this is back to being a 12. If that's a 12, right now we're all good, but if I change this to be plus, now we still can't cancel, because even though one's on top and one's on bottom, and even though they can both be divided by 3 or 4, or sorry, 2 or 4, 12 can't be divided, or 8 can't be divided by 3. But the rule that we're missing here is that we are adding, not multiplying. So we can't do that because the first rule is not being met. So it's only in very specific cases can you do this. Let's see some of those cases and how they work. So the first fraction set here, 15 over 28 times 21 over 10. Now, once you're done canceling, all you have to do is multiply the top numbers together and then multiply the bottom numbers together. And theoretically, you could do that anytime you want. I could do 15 times 21 and get my top number, 28 times 10 and get my bottom number. And that will get me my answer, but I'd have two really big numbers that I then have to simplify through the fraction, because I want my answer in the simplest form. So rather than multiplying these big numbers as they are, I'm going to reduce their size a tad bit. So let's look at the first two numbers, 15 and 10. One's on top, one's on bottom. We are multiplying, so the first two rules are met. Now we need to figure out, is there a number I can divide both of those by? And it just so happens there is. I can divide them both by 5. So let's see what happens there. 10 divided by 5 is 2. 15 divided by 5 is 3. All good there. 3 and 2 don't cancel, so I have to leave them set, and now I go to my next set of numbers, 28 and 21. Let's see if those cancel with anything. Well, can't do a 2, because 21 doesn't do a 2. But 21 and 28 both can be divided by 3. 28 divided by 3. Actually, 28 can't be divided by 3, my bad. 21 can, but 28 can't, so that's unfortunate there. Let's see here. 28 can be divided by 4, I believe, but 21 can't, so that's unfortunate there. But we do have a 7, though. 7 can be going to both of them, so a little bit higher number there. So 28 divided by 7, that's going to give me a 4. And 21 divided by 7, that's going to give me a 3. Again, a lot smaller than what I had before, right? Now, once we're at this point, I check my numbers again. 3 and 2, nah, those don't cancel. 3 and 4, nah, those don't cancel. The 4 and the 2 could cancel, but they're both on bottom, so that second rule isn't met. 3 and 3 as well, but again, they're both on top, so that second rule isn't met. So this is about as far as I can go with canceling. So my two new fractions are this: 3/4 times 3/2. And so what do I do here? Well, I just multiply my top numbers together. 3 times 3 is 9. My bottom numbers, 4 times 2 is 8. So my answer is 9/8. And that's all there is to it. So you cancel, reduce all your numbers. And then once you've reduced as far as you can, you just multiply together what's left. Multiply the tops together, multiply the bottoms together, and then you're done. And as I said before, you don't necessarily have to cancel. You could multiply 15 times 21 and then 28 times 10 and get your two numbers that way for your fraction. But then you'd have to cancel that fraction that's going to have a lot bigger numbers than what I have here. So most people prefer to work with a lot of smaller numbers than two big numbers, because typically you can reduce a lot of smaller numbers easier than simplifying two big numbers. Now, what if they throw a whole number in there, which they will every now and then? Well, if they throw a whole number, you have to remember that every whole number can be written as a fraction by simply putting it over 1. So 3/20 times 12, I can rewrite this as 3/20 times 12 over 1. And that way I have two fractions now, and I can work with them just like I would any other fraction. So let's see how this goes here. 20 and 12, do they cancel? Well, I can divide them both by 2, right? So let's do that. 20 divided by 2 is 10. 12 divided by 2 is 6. And if I look at this, I see I can still cancel some more, right? Because 6 and 10 can also both be divided by 2. So 10 divided by 2 is 5. 6 divided by 2 is 3. Whoops, 3. Now 3 and 5 is where I'm stuck. I can't do 3 and 5 anymore. And nor can I do 3 and 1. So this is about as far as my reduction is going to take me. So 3 over 5 times 3 over 1. If I multiply those together, 3 times 3 is 9 again. 5 times 1 is 5. So I get 9/5 as my answer. Now, just to show you it could work without canceling, I'm going to try something here. I'm going to rewrite this as the exact same original problem. 3 over 20 times 12 over 1. Give myself some space here. If I didn't cancel, here's what would happen. 3 times 12 is 20 or 36. 20 times 1 is 20. And then I'd have to look at this fraction and say, what can I divide 36 and 20 by to simplify it? Well, if I divide the top by 4 and the bottom by 4, I get back to being 9/5 as well. So if you don't cancel, you can still get the right answer. You're just going to be reducing two big numbers rather than four small numbers. So it's theoretically up to you, although usually canceling is a lot easier and will help you out when we start using variables and stuff in fractions. Canceling is going to be very, very, very helpful in that regard. So it's good to have an idea about how to cancel, even if you don't like to do it. And then the last one here, again, 24 is a whole number, so I'm just going to put it as 24 over 1 and just leave it there. 24 and 18, I see they're both even, so the first thing I would do is divide them both by 2. I get 12 and 9. And then 12 and 9 I can still divide out. 12 and 9 can both be divided by 3, so it'd be 3 and 4. And I think at that point, that's when I'm done with my reduction, because if I have 4 over 1 times 5 over 3, I can't do much further than that. So I'm going to go ahead and multiply my top numbers. 4 times 5 is 20. 3 times 1 is 3. So 20 over 3 would be my answer. So once again, the idea here is to look at your two fractions, cancel the numbers that you can cancel, reduce them down, and then multiply the leftovers. Now again, if you don't want to, you can theoretically do it without canceling, but you should know how to do it with it, because later on, when you start working with fractions with variables and polynomials in them, you're going to want to cancel. So at least know how to cancel even if you don't want to. But your fractions answers should always be in simplest form regardless. Now division is, as I said, 99% the same thing, except for one trick at the beginning. And that is, you have to flip the second fraction, which is called getting the reciprocal, before you actually multiply. So we don't ever really divide fractions. We always change a division problem into a multiplication problem, and then we work it as if it was a multiplication problem. So we avoid division of fractions completely, and the way we do that is we perform that flip on the second fraction. So that flip allows us to multiply rather than divide. Let me show you what I mean. So 8/15 divided by 14/9. Well, I'm going to flip the second fraction before I even try to cancel, because remember, I can only cancel if I'm multiplying. Right now I'm still dividing. So I'm going to flip this to be 14/9. This is going to be 8/15. And the division is going to flip to multiplication. Once I'm at this point, that's when I start doing my normal routine. That's when I can go ahead and cross-reduce or cross-cancel to my heart's content if I wanted to. And in fact, I did make a mistake here. I should have actually flipped this fraction, not rewrote it the same way. My bad there. 9/14, because I have to actually flip the fraction. Now I can go ahead and do that. Sorry about that. So now, once I've actually flipped the fraction, that's when I can go ahead and continue my multiplication. And like before, I'm going to cross-cancel before I start my multiplying. That way my numbers are a bit smaller. So 15 and 9, they both share a 3. So divide this by 3, I get a 5. Divide that by 3, I get a 3. 8 and 14, they both share a 2. So that's going to be divided by 2 and get me a 4. That divided by 2 is going to get me a 7. And I think that's about it for my canceling. So I'm going to go ahead and multiply what's left here. 4 times 3 is 12. 5 times 7 is 35. And there's my answer, 12/35. Again, it's flip and then multiply, and once you get to the multiply step, it's just whatever you know about multiplication. So if you can multiply fractions, you can divide them just the same. And just as before, if you have a whole number, you just put that thing over 1, and now you have a fraction. So in the second problem, I would rewrite my first fraction, because that doesn't flip. 6/1, turn to 1/6, and then, as I did before, cancel and multiply. So 18 and 6 can both be divided by 6, actually. And then now I really have a simple multiplication because my second fraction is just 1/1. So 3 times 1 is 3. 7 times 1 is 7. Bing, bang, boom. So again, flip and multiply. But do nothing before the flip. You have to flip before you cancel. Before you do anything else, you have to flip. So don't do anything. Don't cancel. Don't try to change anything. Just flip the fraction first and then go do what you're going to do. Same thing for the last one. Put that 20/1. But again, I don't flip the first fraction. I only flip the second. So 21/1 times 10/9. Again, I only flip the second fraction. 21 and 9 can both be divided by 3, which is good, because I really don't want to have to deal with these big numbers. And I think that's about it for my canceling, actually. Only a little short canceling there. So 7 times 10 on top. 7 times 10 is 70. 1 times 3 is 3. So I have 70/3 as my answer. Again, if you can multiply, you can divide. All you have to do is memorize one extra step, and the extra step is to simply flip the second fraction. That's it. Now the question is, why does this work? How can we go from a multiplication, or sorry, how can we go from a division to its complete opposite, multiplication, and still get the correct answer? Because all these answers are correct. How can we do this by doing one problem the exact opposite the way it says? Well, that's basically because we do the opposite of the opposite. It's kind of like saying in English, you don't not like something. If you don't not like it, that means you like it. You did a double negative. It just means positive. So if I divide a number, I can simply reverse that number and multiply and do the same thing. Because I reversed my operation, but I've also reversed the number. I've flipped it. So that means that everything is still balanced out because I did one switch and then I performed another switch to counteract that. Let me show you what I mean with an example here. 1/2 is probably the easiest one to see this with, okay? Because 1/2 can be done in one of two very clear ways. If I want to take half of something, I can either multiply it by 1/2 or divide it by 2. Cutting something in half is the same as dividing by 2. Cutting something in half is the same thing as multiplying by 1/2. We should all know what half of 17 is. If you don't, half of 17 is going to be 8.5. So both these answers should give me 8.5. Well, let's see. Half of 17. 17 divided by 2. I'll let you try the long division out if you want to pause it and try it out. But you do indeed get 8.5 here. Now, let's write that. Well, let me pause that for a second. Let's try the next one here. 17 times 1/2. Again, put this over 1. Can't cancel anything. So this is 17 over 2. Remember, as I told you last time, fractions are basically division problems. So 17 over 2 means exactly that. 17 divided by 2, which is 8.5, as we saw in the first place. So this problem and this problem have the exact same answer despite saying two separate things. It's kind of like, again, with fractions, saying you have 2/4 of something rather than saying you have 1/2 of something. You both have the same amount, it's just in a different form. Because, as I told you before, this can be rewritten as 17 over 1 divided by 2 over 1. As we just said before, this means flip the second fraction and then multiply, and then now I'm back to the other one here. So even though these problems look very different, they're actually the exact same problem, just written with a different symbology. But that's why this flip and multiply trick works for division. Because I can take a number, as long as I reverse the number, I can reverse the sign as well, the operation. Because I've done two switches, that's counteracted both each other, so I'm back to doing the exact same thing. It's kind of like saying I'd take 17 plus -3 and 17 minus 3. If I add -3 to something, I'm basically taking away 3 things. Again, negative means take away. So if I add -3, or if I subtract 3, I'm doing the exact same thing, even though one says addition and one says subtraction. So it's a little bit strange that we can do this, but there is a reasoning to it, as I just showed here. So trust in the method. It is correct. And as long as you remember to flip and multiply, you shouldn't have any problem with division. So that's how to multiply and divide fractions. Hope you enjoyed the video. Have a good day.